The nuclear industry stands at the precipice of innovation, tasked with advancing nuclear technologies while tackling challenges like efficiency, safety, and material performance. Enter the Idaho National Laboratory's newest facility, the Sample Preparation Laboratory, a game-changing addition to the U.S. Department of Energy's nuclear landscape. As the first hot cell facility constructed in nearly 50 years, this lab is setting new standards for collaboration, efficiency, and innovation. Equipped with the autonomous robotics and modular capabilities, it's designed to provide critical data on material performance in extreme environments while enabling broader collaboration across academia, industry, and government. And to walk us through this exciting development and its implications for utilities, researchers, and the energy sector at large, we're joined today on Power Perspectives by Colin Judge, one of the key figures behind the groundbreaking initiative at INL. I'm Jason Price, your host, coming to you from New York City, and joining me as always, podcast producer's hot seat is Matt Chester from Orlando, Florida. Matt, talk to me about the impact that experts from the National Lab bring to the Energy Central community on a regular basis.
Yeah, thanks, Jason. We have regular insights shared to the Energy Central community from numerous national labs, from Oak Ridge National Lab to Pacific Northwest National Lab, Lawrence Berkeley National Lab, to Colin's home at INL, and more. And it's true what they say that the DOE National Labs, they're a unique crown jewel in the U.S. energy space. So when experts from these labs come to share their case studies, their announcements, their events, and more, the Energy Central community, they rightfully pay attention. And that collaboration at the nexus of academia, make our utility space such an exciting one. So I'd say that bodes quite well for today's episode and conversation.
Yeah, thanks, Matt. And I'm sure today's episode will be another great example of those insights. And I also want to thank West Monroe, our sponsor of today's show. Now let's bring our guest in for the conversation. Colin Judge, welcome to Energy Central Power Perspectives podcast.
Thank you, Jason. Thank you, Matt, for having me on this. I'm very excited for today's conversation. I think we're going to be able to have some fun talking about our brand new nuclear facility here at Idaho National Laboratory, the Sample Preparation Lab.
Yeah, absolutely, Colin. We're really thrilled to have you here and appreciate you taking time out in your busy schedule. Let's start with you breaking down for us this Sample Preparation Laboratory, what it is, what's the work you're doing, and why is this important for the wider energy industry?
Certainly. So, the brand new facility we have is called the Sample Preparation Laboratory. This name doesn't necessarily give it justice. I like to call it the Structural Properties Laboratory because it better fits what the building was made for, which is the study and advancement of qualification demonstration of reactor structural materials. So we're filling in a little bit of a gap that we have within our infrastructure in the United States with a brand new dedicated hot cell facility that's focused not on the fuel systems, not on alpha containing materials, more on the beta gamma structural components, your reactor internals, your reactor pressure vessel steels. So what this facility is bringing forward is a new modern approach to execution of work within shielded enclosures. This is the first hot cell that we built in Idaho National Laboratory in over 5 decades. So this brings new capabilities, new advancements, an opportunity to expand collaboration. Some of the areas that we're really focusing on is the introduction of in-cell robotics. It's quite costly to have space inside of a hot cell to execute our work. We have shielded windows so you can visualize what's happening, and most work is done with traditional manipulators, performed with different operators executing the work inside of those hot cells. Work that we've done now here at INL with the Sample Prep Lab is introducing robotics and camera systems inside of those hot cells. They bring in new advantages for our ability to set up autonomous behavior and autonomous operation. Robots can be very much more dexterous in their ability to handle and manipulate samples inside of those environments. And it can lead to greater efficiencies and improvements as we're executing over manned operation. Now, these are not true robots that are completely autonomous. They are collaborative, or you can coin them cobots. So you can still go in and either operate these robots in a traditional sense with visuals and cameras and manipulating them by hand, or you can use things like an Xbox controller inside of those environments and execute that work when human intervention is necessary. These are just some of the opportunities that this facility brings forward. But beyond that, the facility was largely brought forward to really be a central hub to enable collaboration within the United States. If it's working with academic institutions or working with other Department of Energy laboratories. We really wanted to expand our outreach and utilize infrastructure investments that were made across the United States, not just here in Idaho, to execute that broader mission for nuclear energy in the Department of Energy.
That's great. I want to ask you about that. So these partnerships with utilities, with universities, and the entire energy sector abroad. Can you elaborate? What are some of these new opportunities that you're performing that you can share with us? Any of these coming to market, just to help us understand like the kind of contributions that are coming out of this?
Certainly. So, in the last few years, there's been a resurgence of nuclear interest and nuclear energy interest, looking broadly at trying to triple the nuclear capacity within the United States by 2050 is our large, broad goal. And in doing that, we're looking at not only providing facilities and capabilities and expertise within the National Lab Complex to help with extending the life of existing reactor technologies, working with reactor vendors, working with utility partners to extend the life of the reactors beyond their original design life of 40 years to 60, 80, and up to 100 years. There's a lot of research needed in material science, and this is largely structural components, not the fuel systems necessarily. So having facilities that can accommodate additional work scope is necessary. But beyond existing technologies, we're looking to push the bounds to higher temperatures and more extreme environments so that we get greater efficiencies in reactor technologies. So small modular reactors or microreactor technologies that we're talking about quite often now. And having a facility that's capable of testing those materials, not the fuels necessarily, but testing the materials so that we can support qualification efforts of these vendors to go and get licensing so that they can then transition into commercialization.
Okay, that's really interesting. So it's not just extending the life of existing nuclear reactors, but it's also looking at new technologies, new models like the small modular reactors that are out there on the market. So, the most popular one, of course, is the work around Bill Gates, and is I think it's terawatts. Do you have anything to add or share? Like, are they doing are you collaborating with them, and what are we learning in the small modular space? And is that
right? So, power with Bill Gates. I know there's space that we have, and we're doing work with many different reactor vendors right now here at the lab. A lot of our work is focused on the fuel systems. How do we aid in fabricating new fuels? How do we test those fuels with the advanced test reactor? A lot of that mission scope is work that we are currently executing in our existing facilities at Idaho. These are some of the challenges that we're facing, and it does highlight the importance of what the sample preparation lab is bringing forward. Right now, with so much work coming through our facilities, we are doing all of the fuels and fuel development work and performance testing in our hot fuel examination facility. This is the largest open area hot cell that we have within the United States. It's argon backfilled, so things stay pristine. But we're also using this hot cell for performing structural materials testing currently. So we've effectively created a little bit of a bottleneck within our infrastructure where all of this work is being done in the one facility. And now enter in the sample preparation lab, we're able to optimize our testing performance and testing schedules so that we can shift and augment all of the structural work into this brand new facility. And it opens up more space within that facility to execute some of that interesting work for those vendors as well. That is one of the big opportunities that it poses for us. But beyond that, the real benefit is when we bring things into the sample preparation laboratory, we're not contaminating materials with alpha or with particles of fuel. And currently, everything in the hot fuel examination facility over its 50 years of operation is contaminated. We bring this material into the cells, we section it, we segment it, and there is some contamination within that facility. So if I wanted to collaborate with a university on structural materials, I would section materials and then need to ship it to them. They're rather restrictive on their ability to handle alpha contamination. So having a facility that's clean of alpha, like SPL, gives us opportunities to take advantage of the infrastructure investments we've made within the United States over the last 30 years. We can collaborate with other DOE laboratories, other academic institutions, as well as commercial hot cell facilities that otherwise struggle with handling alpha. So one of the big pushes that we have within SPL is we can start taking advantage of the significant infrastructure investments within the United States, or look broadly with our international collaborators to execute the experiments faster and more efficiently. So if we are really going to succeed in tripling nuclear capacity by 2050, we're going to have to decrease the timeline it takes to qualify new materials. The materials that we're looking to work through to these extreme environments, higher temperatures, different corrosive environments like molten salts, we've code accepted those materials, but they have not been fully characterized in those environments. We haven't irradiated all of those materials at higher temperatures and tested them in the extreme conditions that they're going to be exposed to in a reactor. So yes, SPL can help with doing that testing, but it also acts as that cornerstone for the industry that we can also collaborate and ship materials to others, use them as an extension of our own capability, and do things faster. And that is absolutely crucial for our ability to be able to deliver on this broad goal of achieving enhanced and greater nuclear capacity within the U.S.
Colin, you know that our audience are the utilities, so let's talk about that audience for a moment. And assume they're listening in, and hope they are. A lot of utilities own or operate nuclear power plants. So what is the role of the sample preparation lab when it comes to utilities? How are you supporting them? How are you looking to modernize or adopt any kind of new best practices? Just talk to us. What's the crossroads look like for the sample prep lab and the utility industry?
So we've been working very closely with the Electric Power Research Institute, some of the different working groups, and some of the staff members and management team within EPRI act as advisors on our external advisory committee. So what scientific equipment should we be installing within our facilities? How do we want to go through our external engagement strategies? And we get good input from them, and they are a really good conduit working with our reactor utility members and potential customers. So working with different utilities, it's really trying to understand and communicate at what matters most to them. At a DOE system where we're operating, we get caught in the middle between scientists who are very curious individuals, very greedy. They want a lot of really good scientific data to work on, and they're very excited about pushing the limits and understanding behavior and mechanisms. Reactor utilities, I don't want to say don't care about that. They absolutely do, but they care about it in the perspective of operability. How does this work matter for me? How do I continue to operate, and how do I continue getting that work done? How do I do a fitness for service on a component that I might have some questions on? We can work typically through EPRI, or work directly with utilities if they so wish, to take those materials, harvest them from their operating reactors, send them to us, and we can perform testing to give them greater confidence on safety, as well as assess safety margins for fitness for service. So do they have a challenge? Do they have a problem? Or is everything operating the way that they originally designed it to? This is something that this facility definitely can aid in. And beyond that, I know when we're doing work with utility members, a lot of them would like to participate in the work that we're doing and be present. Now, Idaho is a beautiful place to go. I love the mountains and I love the outdoors, but it is relatively remote by design. When the original design for this facility came in, it was the National Reactor Test Bed. But in this specific application, it's in a remote location in Idaho. So it's difficult to get to from different locations around the world. So if people would like to collaborate and see our work, one thing that we put into the design of this facility is its telework possibilities. We do have cameras in our hot cells. We have the ability to connect with individuals who are across the United States so that they can see the work that we're doing while we're doing it in the hot cell and feel a little bit more engaged in the activities that we're working on. So from a utility perspective, this offers great opportunities. From collaboration with universities, teaching moments and mentoring with the next generation of highly qualified technicians, operations, and scientists, we get a little bit more connectedness. Even though we are remote, we can almost make ourselves feel like it's a part of either university campuses or those members in cities and major centers that reactor vendors specifically are. Does that make sense, Jason?
Yeah, absolutely. No, thank you for that. All All right, so let's do the following. Let's zoom out. Both, you know, and you've already elaborated on some of this, but certainly, summarize if you can for us. What are you able to do now that you weren't able to do before? Now with the sample preparatory lab, but then also take us a step further. Where do you see the lab and the kind of work it's going to be delivering, say, like 10, 20 years out?
So, it's a great question, Jason. One of the things that we put into the design for the sample preparation lab was space. We did not build this facility for what we need today. We built it for what we not only need today, but what we believe we may need in the future. And that incorporates space. So we do have a primary hot cell, and we have room for growth. So on our main floor, we have space for additional modular cells as necessary, growth for doing additional test equipment. So it's really that constant engagement and constant updating of our investment and infrastructure strategies so that we constantly meet the needs of the next 5, 10, 20 years. And we've built in flexibility in the design associated with the facility itself. Let me expand a little on that. When we work with either reactor vendors or utilities, often we will get requests for new kit, new science equipment, new testing capabilities to be installed within shielded enclosures to execute the work that's very specialized to their needs. This is really expensive and time consuming if we're going to go to previous facilities we have. New feed throughs going through the walls need to be considered. New design features need to be put into place. There's not a lot of flexibility in existing facilities in the United States to accommodate that in a way that would make sense for us to do it in the timely manner that the vendors are trying to accelerate qualification and licensing. But also it's cost prohibitive. It takes a lot of money and investment. Within SPL, we have shielded enclosures. So we have a primary main cell, and then we have shielded enclosures that have some scientific equipment that are direct connected to our main hot cell through pneumatic transfer tubes. Those old bank vaults where you send letters across facilities. Very much the same concept and design. You put in specimens into those capsules, and then you can shoot it across the facility into these shielded enclosures. And each enclosure has a robot, either on a vertical gantry system, so you have one robot that can move everywhere in that one enclosure, and we can execute our more advanced scientific testing. One of these enclosures, which is about 12 foot by 12 foot, about 10 foot tall, was designed completely empty. And the versatility that this offers is it is an experimental test bed so that we can work with vendors, we can work with external customers who have a campaign of testing that they would like to do, very specific to their needs. So we can get that equipment, install it, have it set up to execute a campaign of either 6 months or 1 year, and then wheel it out into the main floor of our hot cell floor and our main floor of our experimental hall, and then bring in the next experiment and ready it for our next customer. Previously, that would take a 5-year iteration to try to execute something along those same lines. We're now looking to try to do almost on a monthly basis as necessary. So this is a big opportunity moving forward that'll decrease the cost of executing experimental work, increase our overall mission capabilities, and gives us an opportunity to do more for less.
It doesn't sound like I can go to my local hardware store and build one of these.
No, certainly not. And we've taken advantage of some of the other facilities at INL that we've built in the last 15, 20 years. We don't have those exact capabilities, but we have similar things that have gone through different iterative designs. So it's not something we've just decided one day to flip a switch and say we're going to do this. We've slowly incremented little changes. So we have right next door to the sample preparation lab is our irradiated materials characterization laboratory. And this is a 40,000 square foot facility that has some of the world's best high-end material characterization equipment all in one building. So, the capabilities we have here are direct coupled not only to that facility, but also the fuels facilities, so that in one very close proximity, we have some of the best capabilities for testing structural materials and irradiated fuels that exist anywhere in the world.
You said a couple of things. I want to make sure I understood correctly. Did you suggest that the sample preparatory lab is not fully operational. It's still in development, or just where's the lab in its operations? Is it?
So we did our main ribbon cutting in August. So the facility itself is done. We've moved in. So the scientists have moved into the facility, and we're working very closely to install the scientific equipment now. We are not hot yet. So we're not doing radioactive work or radioactive testing. We're in the transition where we're installing the scientific equipment. We're getting the facility ready for management safety assessments, MSAs, and operational readiness reviews. So these are required anytime you have a new capability. You're going to run through the what if scenarios. What if I drop a sample? What if one of my robots in the hot cell go down? What's the recovery pathway? We ask these questions and we run through these scenarios so that we're not surprised when we go hot and we're doing, figurative hot work and radioactive work. We want to run through the scenarios such that our procedures and our operating conditions are all set up so that we can minimize surprise. And we get ourselves to a position that we've made all of the accommodations and all of the necessary planning in place so that when we do eventually come into one of those scenarios or situations, we've already thought about the path forward and we're ready to execute. So over the next year, so we operate in our fiscal years, Jason, so we operate in October to September timeline. By the end of this fiscal year, we're going to be ready to go through our operational readiness, and we plan to have the facility fully operational, ready for hot work by January of 2026 is our targeted timeline.
Okay. So, Colin, you've continued the tradition with INL guests of bringing just a phenomenal, insightful, and fascinating discussion to our members at Energy Central. So you've continued that tradition, which is great, and I want to thank you for that. And we're going to give you the final word, but the not so great news is that we're now going to put you through what's called the lightning round, which is where we get to throw a series of questions at you. We ask you to keep your response to one word or phrase, and I'm sure you're going to do great. So, Colin, are you ready?
Let's do it.
All right, here we go. What's a book or resource you'd recommend to someone new to the energy sector?
Book in the energy sector. That's tough. There are a lot of different resources. Something that I keep finding myself going back to. There's a really, really good book. It's a field guide for understanding human error by Sidney Decker. And I think that's not necessarily exclusive to the energy sector, but for the type of work that we do within DOE laboratories and operations, scientific work that we're doing, I think it can have great applicability if you're in a hospital setting or any area that you're following, process and humans can make mistakes. I think it's an inevitability that error is going to take place. And if we can understand it, I think that's really going to help us. That's much more than one word, Jason. So forgive me, but that I think is one that I can recommend to others to read.
Quite all right. We'll make sure we highlight that on the show notes. All right. So what's the most rewarding part of working at INL? And I'm going to add, you can't say cafeteria.
Oh, I would never say the cafeteria. They don't serve poutine, Jason. So, no, the most rewarding, I have to say, so I get to work in a place that has some of the world's best scientific equipment. And I get very privileged. I'm in a management role, but I'm still a scientist and an engineer at heart. I get to work with brilliant people every day. And we get to bring in new brilliant people every day with new staffing opportunities. So just seeing people come in through the door and do some of the fantastic things that they're doing here to advance nuclear is really a privilege, and it's really an honor to be a part of. And finally, I have to say the one thing I really, really liked coming here, I was not hired here 6 years ago in a management role, but I've transitioned into it. I really admire the fact that we have a management team that's aligned. We have unified goals. We're working very closely with our customers, and everybody on our management team seems aligned with the mission that we're trying to drive. And that's something that is really, really, really something that I can get behind.
No, thank you for that. What does the future of nuclear energy look like?
Hot. And pun very much intended. No, it's a very exciting time for nuclear energy. There's a lot of hype and a lot of excitement coming on right now, and I have to say, in my career, it's really refreshing to see. We went through a little bit of a recession in nuclear energy and not a lot of new builds. And right now it seems like there's a lot of agreement not only within the United States, but internationally, that we need nuclear energy. And we need to establish some good, strong, and reliable baseload power. So I think, I say hot because I think we're going to get a lot more nuclear power technology starting. And I think that's going to be very exciting.
All right. And now it's your turn. What lightning round question do you want to challenge a future guest to answer? And keep in mind, Colin, it can be energy related or it could be an off the wall question.
I'm going to stick to the theme that I was talking about here. And I spoke about some opportunities, but we do have this broad goal of tripling nuclear by 2050. And that's quite ambitious. And I like ambitious goals. But everybody I've spoken to and I've asked this question to in the past has a different answer. So I'm really excited to hear the perspectives from different participants and maybe future podcasters on your channel here. What do you think the biggest challenge is for us to achieve tripling nuclear by 2050? Is it the supply chain? Is it licensing and regulation? Is it the designs going through their different considerations? There are many different factors for this, Jason. So it's a loaded question.
That's a great question, though. And thanks for raising it. So, Colin, the last question, and then we're going to give you the final word. So the last question, though, is who are your role models?
I'm going to give the cliche answer and say my father is one. He taught me that it's not only important to work smarter, but you also have to work harder. And those who succeed are people who can do both. And they're not mutually exclusive. I know most people will say work smarter, not harder. I think you have to do both. And finally, from a work setting, I was very fortunate. Being Canadian, I worked at Canadian Nuclear Lab, and I worked very closely with a mentor I had at the time, Dr. Mike Wright. He stressed the importance of being able to speak plain language. We had to work very closely with nuclear utilities. We have to speak in the who cares and why is it important. But at the same time, be able to speak to our scientists in very fundamental languages on why we're curious and really kind of going down into the weeds. And being able to kind of come up with a Rosetta Stone to kind of go between those two worlds was something that I don't think comes naturally to many people. And having that urgency and having that stressed to me early in my career has really helped me get to where I am today. Hopefully, it's going to help me get to where I plan on going in my career moving forward. That's
great. Thank you, Colin. Thank you for indulging us on the lightning round and getting to learn a little bit more about you, the person, rather than just the professional. So thank you again. I did say I was going to give you the final word. So knowing that you've got decision makers across the power industry listening in, what's a few of the key insights or takeaways you hope that they take away from today's discussion on the sample preparation lab and the future of the U.S. nuclear industry?
So one takeaway I want to stress, and it doesn't matter if it's a reactor utility, if it's something from the private sector coming in with reactor vendors, or other Department of Energy laboratories, university partners, and collaborators. I want to stress the importance of this new facility. Oftentimes, people will see a new lab popping up within a DOE laboratory or a new facility in a DOE laboratory, and think that the people working there are looking to take over that domain and execute that workspace. And that is absolutely not what we are trying to do in Idaho. There's a statement. Last year, I spent, and I had the good fortune to be able to travel to all 17 DOE National Laboratories in 2023 as part of the Oppenheimer Science and Energy Leadership Program. And among the different DOE members, there are a few terms called coopetition or competition. And they're two made-up words. We are fortunate that we get to collaborate among our peers constantly, but we're also naturally going to compete over resources and funding to execute that work. I don't want people to see the fact that we have this brand new facility as INL is here to do it all. We are absolutely not here to do it all. What I'd like people to see is that we're here to enable collectively us to do it all. So if facilities exist elsewhere, I don't need to install them in my facility. I can empower and enable them by leveraging the ability to bring in materials to our facility and ship it to them to execute that work. So we can get more out of their facilities at the same time as we're also doing more work here, and we can do things faster. So I really want people to embrace the fact that this facility is here, and the culture and the attitudes of the scientists that are here working in the facility are open to really meet the needs of our customers. We're going to try to collaborate more, and we're going to try to execute a lot more. And something I've very much had most of my career is I want to use other people's facilities as an extension of my own, and I want them to use my facilities as an extension of their own. So that's really one thing I very much want to stress for everybody who's listening. And if anybody has any questions, they're more than welcome to reach out to me to see how this facility can help them. Or they're welcome to reach out to any member of INL, and they can get them in contact with me or any member of my team. And we're here to engage and help advance nuclear energy.
That's great, Colin. I mean, I feel like your comments are very consistent with other INL members that we've had on the show. So it's a common theme that is expressed by your peers, and thank you for reinforcing it. And I have no doubt that the listening audience will pose questions to you on the Energy Central platform, and when they do, we'll invite you to hop back in and keep the conversation going. Until then, though, we just want to thank you for sharing your insight on today's episode of the podcast.
Absolutely. Thank you so much for having me, Jason.
You can always reach Colin through the Energy Central platform, where he welcomes your questions and comments. And we also want to give a shout out of thanks to the podcast sponsors that made today's episode possible. Thanks to West Monroe. West Monroe is a leading partner for the nation's largest electric, gas, and water utilities, working together to drive grid modernization, clean energy, and workforce transformation. West Monroe's comprehensive services are designed to support utilities in advancing their digital transformation, building resilient operations, securing federal funding, and providing regulatory advisory support. With a multidisciplinary team of experts, West Monroe offers a holistic approach that addresses the challenges of today and provides innovative solutions for a sustainable future. And once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion, hopping into the community at energycentral.com, and we'll see you next time at the Energy Central Power Perspectives Podcast.